So, one thing that's been really bugging me lately is this whole trend with early onset colorectal cancer.
Oh, yeah.
It's, cancer diagnosed before the age of 35.
Right, right.
And it's just crazy how much it's been increasing. The numbers are, like, seriously alarming. From 1990 to 2021, we saw a 49% jump in cases in the U.S. alone.
Wow, 49%.
Yeah, it went from like 6,200 cases a year to over 9,300.
That's a huge increase.
And the really scary part is that the age standardized incidence rate went up even more by 34%.
Oh, wow.
And this is hitting women, especially those born after 1983, particularly hard.
That's really concerning.
It's like, what's going on? What's
Right.
changed?
It really makes you wonder what's the root of this.
Yeah, and the thing is, the traditional treatments for colorectal cancer, they're tough. They come with a lot of side effects and they don't always address those underlying causes.
Right.
Plus, the early symptoms can be so subtle, so easily mistaken for something like IBS.
Yeah, I'd be
This makes early diagnosis a real challenge.
absolutely. It's a tricky situation.
So we're diving into something really fascinating today. We're going to explore the role of our gut microbiome in all of this. The research we've been looking at suggests that those changes in our internal bacteria, that ecosystem in our gut,
Yeah, microbiome.
might be playing a much bigger role in this rise of early onset colorectal cancer than we ever thought before.
I think you're right. There's definitely growing evidence pointing in that direction.
Okay, so let's get into it. One of the big ideas we keep seeing is this hypothesis from Dr. David Kerr at Oxford, and it centers around the changes in our diets over the past couple of decades.
You mean like the shift towards processed foods?
Exactly, that's a big one.
Yeah, it seems like that's been a huge factor.
Dr. Kerr thinks that this massive shift to processed foods has actually altered the environment inside our guts, like the balance of our microbiome.
Right. Instead of having this diverse and beneficial community of microbes, we might be accidentally creating a setting where bacteria that can produce harmful stuff.
Like those mutagenic chemicals.
Exactly, those chemicals that damage our DNA.
It's kind of scary to think about.
It is, and the research is really starting to explore this. There are global studies happening right now comparing the gut bacteria of younger and older colorectal cancer patients.
That's interesting.
They want to see if there's a link between early exposure to these mutagens, like colobactin, and developing cancer at a younger age.
Colobactin, that's one of the ones that really stood out to me.
Me too. And there are a couple of specific bacteria that are really on the radar, like Fusobacterium nucleatum and a type of E. coli that produces colobactin.
Yeah, it's not like they're just hanging out in there. They seem to be playing a part in how the disease develops.
Right, they're not innocent bystanders.
So this PKs plus E. coli, the one making colobactin, it's getting a lot of attention because colobactin is a known mutagen.
I mean, it literally has the power to change our DNA.
And Dr. Kerr and some other researchers have pointed out that scientists have linked exposure to colobactin with this very specific pattern of mutations in tumor cells.
That's right, it's like a fingerprint.
And the thinking is that if we're exposed to this mutagen early in life, it could lead to what they call a higher tumor mutational burden later on.
Like the more mutations that accumulate in a tumor's DNA, the worse the prognosis might be.
That's the idea.
Wow, that's sobering.
It is, and this whole concept of early exposure really resonated with me.
I get it. It's like these early insults to our DNA are setting the stage for something much bigger down the line.
Exactly. And we also came across a review in the World Journal of Gastroenterology that really supports this whole thing about a disrupted gut environment in people with colorectal cancer.
Oh, what did it say?
Well, they found significant differences in the types and amounts of bacteria present compared to healthy individuals.
So there are clear differences in the gut microbiome.
Yeah, and the review actually highlighted some specific bacterial suspects. One that stood out was Streptococcus bovis.
Streptococcus bovis, huh?
Yeah, and what's interesting about it is that it can attach to both healthy and cancerous cells in the colon.
So it's not picky.
Nope, and once it's latched on, it starts causing problems. It triggers inflammation, disrupts the normal function of the cells, and even releases toxins that damage DNA.
Sounds like a troublemaker.
It really does. And then there's Fusobacterium nucleatum. This one's really sneaky. It seems to weaken the immune system's defenses around tumor cells.
Like it's protecting the cancer.
Yeah, almost like it's giving the cancer cells a free pass to grow and spread.
And it can make the cancer more aggressive too, right?
That's right. It seems to enhance the cancer cell's ability to move and invade other tissues.
Oh, well. That's not good.
Not at all. And we can't forget about those particular strains of E. coli, the ones belonging to phylogroups B2 and D.
Oh yeah, those are the ones that are known to produce a lot of toxins, including colobactin,
Exactly. They can mess with the normal cell cycle, cause DNA damage, and ultimately lead to genomic instability.
which is like a hallmark of cancer.
Right. So it's not just about having E. coli in our gut, it's about having a higher proportion of these specific, more dangerous types.
So it really is about the balance and diversity of the whole gut ecosystem.
Right. It's not just a few bad apples, it's a whole shift in the environment.
That's a good point. So how does our modern diet tie into all of this?
Well, our sources pointed to the increased consumption of processed foods,
Of course.
especially those high in unhealthy fats like linoleic acid.
That makes sense.
They found that a diet like that can actually harm the function of our mitochondria, those little energy factories in our cells.
And I'm guessing it also increases the production of bile acids, which, as we mentioned before, can be converted into carcinogenic compounds by certain gut bacteria.
Exactly. And the lack of fiber, which is a big problem with processed foods, just makes things worse.
Right. It fuels inflammation and contributes to more DNA damage.
It's like we're adding fuel to the fire.
Definitely.
Yeah.
We even saw some research linking diets high in ultra-processed foods to an increased risk of colon cancer.
It's a serious concern for sure.
It is, and we have to remember the long-term challenges that younger adults face when diagnosed with colorectal cancer.
Absolutely. I mean, they often face decades of potential treatment.
Not to mention the risk of complications from the disease and the therapies.
It can impact their whole lives, their careers, their families.
For someone in their 30s or 40s, a colorectal cancer diagnosis can be life-altering.
No doubt. And from a broader perspective, this rising incidence puts a strain on our healthcare resources.
Absolutely.
It shows just how urgent it is to understand the root causes and develop effective prevention strategies.
We need to find better ways to treat this disease in younger patients.
I think that's where the gut microbiome comes in. If we can figure out the role these bacteria are playing, it opens up a whole new world of possibilities.
You mean like new treatments that target these harmful bacteria directly?
Exactly. Or even interventions that restore a healthy balance in the gut.
It could be a game changer, especially considering the limitations of traditional cancer treatments.
So to sum it all up, the evidence is pointing to a link between the changes in our gut microbiome and this rise in early-onset colorectal cancer. And it seems like our diets, particularly the shift toward processed foods, are a major driver.
We've talked about some of the key bacteria involved, like Fusobacterium nucleatum, those colobactin-producing E. coli strains, and Streptococcus bovis.
And we've seen how they contribute to cancer development, from damaging DNA to promoting inflammation and even helping cancer cells hide from the immune system.
And all of this research isn't just theoretical. It could really change how we approach this disease.
We might see new diagnostic tools that analyze the interactions in our gut bacteria.
And more targeted treatments that focus on creating a healthy gut environment.
What I found really interesting is some research suggesting that F. nucleatum might actually be recruited by early cancer cells.
Really?
Yeah, it's like the cancer cells are calling for reinforcements.
Wow, that adds a whole new layer of complexity.
It does. It paints this picture of a very active role for these bacteria in the development of the disease.
So it's not just a passive process, it's a dynamic interaction.
It is. So, given everything we've talked about today, all this fascinating and sometimes unsettling stuff about the gut microbiome,
Yeah.
I think the big question is, what can we do about it? What changes can we make in our own lives to support a healthier gut environment?
It's definitely something to think about and maybe even experiment with.
It's about taking control of our health, one good gut bacteria at a time.
I like that. One good bacteria at a time.
Well, that's about all the time we have for today.
It was great chatting with you. Thanks for having me.
Thanks for being here.